Proposition 8, Book 2, Euclid. Given a straight line and be cut at random, 4 times the rectangle contained by the whole straight line and the aforementioned segment, plus the square on the other segment, is equal to the square contained by the whole straight line plus the aforementioned segment taken as a straight line. So we have here a straight line cut at random, and here we have our segment. Here we have our aforementioned segment, and here we're going to have our aforementioned segment taken as um, a straight line. So this is equal to this. Thus, we need to show that the rectangle contained by this whole straight line and the aforementioned segment 4 times this rectangle contained plus the square on this segment is equal to the square contained by this whole straight line. So what we're going to do first is we're going to draw our square. First of all, we draw our square. So we're going to draw a square. We're going to draw it. We know that we can draw a square given a straight line, right? And here's our square. Now we're going to draw our diagonal. Draw the diagonal. From this point, we're going to draw a straight line parallel to this and this. So we draw it. There we have. Now we're going to draw from this point of section. We're going to draw another a line parallel to this, and we're going to extend it. So we do it. There we have. And now we're going to do the same thing. Like from this point over here, we're going to draw a line parallel to this and this. So we do it. And from this point of section, we're going to draw a line parallel to this, and we're going to extend it. So do that. Parallel. We extend it. So there. So we have this. What do we know now? We're going to show first that these 4 squares over here they are equal to each other and there are squares. So first of all, we know that this is a square, so this is equal to this, so the angle, this is going to be an isosceles triangle, and the angles at the base are going to be equal to each other. This will be equal to this. And now we know that this is parallel to this, and this line is coming upon these 2 parallel straight lines, creating an interior and opposite exterior angle equal to each other. So this will be equal to this, and the same thing here. This is parallel to this, so this angle is going to be equal to this angle. They're equal. So as these two are equal to each other and these two are equal to the same thing, and this is equal to this, so these two are going to be equal to this, so this will be equal to this, and this will be equal to this. And we see that we have 2 straight lines and creating external angles equal to each other, I mean opposite angles equal to each other. So equal, 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 equal. So this will be equal to this. Opposite are equals. This will be equal to this, and it will be equal to this. Same thing happens to this. Is equal to this because so this is going to be an isosceles triangle. So as this is an isosceles triangle, so this will be equal to this. So this is equal to this, and the same thing happens to here, but this doesn't matter. So this equal to this, equal to this, equal to this. So now we have that this is a square, this is a square. They have the same base, and same base. So therefore, in the same parallels, therefore these two are going to be equal to each other. And as they have the same base, they are also going to coincide because this will be equal to this, and this will be equal to this. So their four sides are equal, and they're are equal to each other. And the same will happen to this and this. So we have that this is in at the same base as this, because this is equal to this. So these two are in the same at the same base. So this will be equal to this, because two parallelograms in the same base and the same parallels are equal to each other. So this is equal to this. And the same with the sides. This is equal to this, and this will be equal to this. So the four sides are equal. So this is equal to this, and as this is equal to this, and this is equal to this, two things equal to the same thing are equal to each other. So this will be equal to this. So the three are equal. And now we're going to show the same thing in the fourth one. These opposites equal, equal. These two are the same base and same parallels, therefore this is equal to this. And now we have shown that these four are equal to each other, and now we're going to show that they are squares. So this is this is a right angle, this is a right angle, these two are parallels, therefore this plus this needs to be two right angles, therefore this is a right angle because this is already a right angle. So right angle plus something is equal to two right angles, so therefore this is a right angle. Opposite right angle, opposite in on a parallelogram, the opposite the opposite angles are equal to each other, so this is right angle. We have here a straight line, a line falling up on these two straight lines, create the adjacent angles equal to two right angles. Right angle, same thing, we use the same reasoning here. Right angle, right angle, right angle, same reasoning here. Right angle, right angle, right angle, and same reasoning here. Right angle, right angle, right angle, and right angle. And also here we can show the same thing. This is a line falling. This is a straight line. A line falling up on these straight lines. Right angle. This is a right angle. Also same reasoning we use here. Right angle. Right angle. Same reasoning here. Right angle. Right angle. Right angle. Right angle. And we use the same reasoning here up. We have that this is a right angle because it's a straight line to straight line, a line falling upon, creating two adjacent equal to each other, equal to two right angles. So this also should be right angle using always the same reasoning. And this also should be right angle, and right angle. So we have shown that these four are equal to each other and that they are squares. And now also we have shown here that as this is equal to this because they are a parallelogram, opposite sides of parallelograms are equal to each other. So and therefore angles are right. So this is a rectangle, this is a rectangle, a rectangle, rectangle, and these four squares are equal to each other. And they are squares and they're equal to each other. Now, what do we have here? Now we need to show that these four rectangles are equal to each other. How are we going to do that? If we see this parallelogram over here, we see that this is a complement and this is a complement, therefore they're equal, and therefore they're equal. And we also do the same here. We have this whole, right? This whole parallelogram, and we can see, sorry, wait. Okay. And we see that this is equal to this because they're in the same base and the same parallels. Therefore, this is equal to this, and as this is equal to this, therefore this is going to be equal to this. The same thing happens here. They're in the same base, same parallels. Therefore, this is equal to this, and as this is equal to this, and these two are equal to this, and so this is going to be equal to these two also. Therefore, we have shown now that these four rectangles are equal to each other.